Okay, folks, one more solution from problem set 2, question number 4. This is the last function in that question, function L, which is sine squared of x. So let's do this. So the tip or the hint that I give in the PDF says to write this out as, first of all, let me write something in the middle. Remember, this means sine of x squared, meaning we're not squaring x, we're taking the sine of x and then squaring that quantity. So that's what that means. This is our notation for that. And of course, sine of x squared means sine of x times another copy of sine of x. All right. So the hint recommends doing it that way, separating it like a product and using the product rule. I believe from last summer when I wrote this, we probably did not do the chain rule together in my class at this point. Because you can also do this using the chain rule. So let me do it with the product rule, then do it with the chain rule. I like to do that whenever I can, just to sort of double check my work, make sure I get the same thing, and practice using both techniques. And I think it's fun. Okay, so if I've got to use the product rule here, or if I want to use the product rule, let me call this guy F and call that guy G. Okay, so that's nice because they're actually the same as each other. And so we know that the derivative of sine is cosine, so F prime is going to be a cosine. So L prime of x. All right. Do I want to show this again with the f prime g plus f g prime? Maybe I want to show that. Do I want to use the d notation, ddx, to illustrate what I'm doing? Maybe, right? So in the previous videos I said, yeah, let's do that. If this is the third one I'm writing up from my professor in a row, and if I've already maybe seen this derivative, or if I think it's common enough, if I think no one's going to get lost with what I'm doing, maybe I'm going to show it a shorter way. So let's say I've got the first function, sine of x, times the derivative of the second function, cosine of x, plus the derivative of the first function, sine of x, times the original second function, cosine of x. All right, there we go. So maybe I showed it like that. Maybe I mixed up the order of the way I wrote all my terms legitimately, but maybe I did that so I would get the exact same copy of the same thing in both spots. So I can do that. If you feel like maybe you are not showing enough, maybe just go back and call this, you know, f, and then here's derivative of g, g prime. And then here I've got f, that would be g, and then here I've got f prime. All right, something like that. So it doesn't always have to be so in-depth. A little bit loose is okay. So when in doubt of how much work to show, it's kind of a balance. Showing more is never bad unless you show something that's inaccurate. But the more you show, sort of the better. Having confidence to show less is also a good thing, but showing enough, so there's kind of a balance. Anyway, what do we have here? Sine times cosine, another copy of sine times cosine, so the derivative here is 2 sine of x cosine of x. Right, and if you're saying, wait a minute, why are we just multiplying by the sine by 2? No, we're not really, because this is one copy of that. There's another copy, so if you want parentheses around there to see that we've got 2 copies, it means the same thing, but since we're multiplying here, 2 times sine of x times cosine of x, parentheses not necessary. All right, so that was a pretty quick one using our product rule. Let's try it again just to practice using the chain rule. All right, so let me get rid of all this. I don't need that representation anymore to help me out, but this representation might still be nice, because here I can say equals u squared, right, if u is sine of x. So that's sort of an alternative to a let statement, but kind of makes some kind of substitution right there. So if I call u sine of x, and there we go, u squared. Okay, so in that case now, the derivative of, let me use my d notation, the derivative of L now with respect to x is, so the first time with this notation you try to write the chain rule, it looks a little bit weird, like where did this extra variable come from? But let's see what we've got now. We've got L of x is equal to u squared. So we have a function of x, but we've represented it now as a function of u. So what that means is we want to take the derivative of L with respect to u. And so that means I'm going to get dl du. Okay, and then usually when we're making this kind of substitution, I want to know the derivative of that, which sometimes we call u prime, which we know is du, the derivative of u. U prime basically means the derivative of u, and then here, since we've got u as a function of x, we want to take that derivative with respect to x. All right, and we know that the derivative of sine is cosine, so there we go. All right. And so since I've substituted u here, I need to know the derivative of that du dx. So it makes sense that I want to use that in the formula. And du dx, if it lives right here, right? So again, we're kind of writing out the formula from here to here. Might feel weird, but once you do it, going back should feel natural, right? Because those du's want to cancel out, leaving dl over dx, which is exactly what we have here. Okay, so if you find the notation helpful, use it. If you find it cumbersome, don't use it. Try to just dive in and tackle your chain rule another way. So the derivative of L with respect to u, L is u squared. So the derivative of that with respect to u is just our power rule, right? Bring down the 2, so we get 2u, right? And then times du dx. I already called that cosine of x. We already found that. So we've got cosine of x. And last thing we want to do is we don't want to leave u. That was a substitution. We want to go back to functions of x. U is sine of x, and so I've got 2 times sine of x times cosine of x. All right. Identical answer to when we did it with the product rule? Yes, and it should be, right? If something went wrong, or if we got something different, then something went wrong with one of our processes, and so then we want to probably double check both of them. All right. But when that goes well, then we're done. All right, folks. If you've watched all 3 of these videos, I'm going to post one more because for homework, I assigned 2 functions which are both quotient rules. And then there's no other ones on this list that are quotients. So I'll do one sort of bonus function, I guess, set up a quotient, take the derivative of that, and then that will be it.